Hello, today I'm going to be teaching you how to fill in the missing numbers of a geometric and arithmetic sequence given the first number and another number. So first thing we need to know is that when we're using our common ratio in geometric, we use that to multiply from the first number to the second, then the second to the third, then the third to the fourth in this case. So we use that 3 times. So we use this 3 times. So now what we're going to do is we're going to list our first number right here. So we're going to have 13. Then we're going to multiply our ratio to how many times we use it. So we use it 3 times. So we're going to put our ratio cubed since we use it 3 times, and then we're going to make it equal to our last number. So it equals negative 4,459. Now we have our equation. So our next goal is to get r cubed by itself. So what we need to do is we need to divide by 13 on both sides. So then we get r cubed equals negative 343 when you divide negative 4,459 divided by 13. Now we see this cubed. So what we need to do to get r by itself is we need to take the cube root of both sides. So now we're left with r equals negative 7 because negative 7 cubed is negative 343. Now this negative 7 is our common ratio. And our ratio, that means that we need to multiply it in this case. So now we need to take 13 and multiply it by negative 7. So it's negative 7. So we get negative 91 as our next term. And then we take negative 91 and we multiply it by negative 7. Or we can just cancel out the negatives and make it 91 times 7. And we get 637. And then just as a final check, we could take 637 and49 it by negative 7. And see if we get 4459. So we get 749. Whoopsies. Should be 5. Should be 2. So 2. And we do get negative 4,459. So we know this is correct. So the next 2 terms in this sequence would be negative 91 and 637. Now let's do an arithmetic sequence. So we want 5 numbers between 17 and negative 60. Now, we're going to kind of use the same method, but we're going to use a common difference instead of ratio. So we're going to count how many times. So 1, 2, 3, goes from here over here. That's 4, 5, and 6. So 6 times. An easy way to remember for both geometric and arithmetic is that it's just how many numbers you need plus 1. So in this case, it's 6. Because we need 5 numbers, and then we add 1 and get 6. So now we're going to take our 17, similar to the first geometric equation, but instead of putting our ratio, or in this case our difference, to the power of how many times we put it, we're going to multiply it by the times we put it, and we're going to add it to our first number. So we're going to add it to 17, and we use it 6 times. So we're going to add 6d. D is for the common difference, just like r was for the ratio. And then we're going to make it equal to negative 60. Now we add 60 because you're trying to get to negative 60. If you start here at negative 60, I guess you'd subtract, but most times you should start with 17 or just the first number of that sequence, and that's what I'm doing now. So just start with the first number. And now, again, we want to get our variable alone. So first we're going to subtract 17 from both sides. And we get 6d equals negative 77. And now we need to, divide by 6. Right? And we get 12.8, or 12 4/5. Oopsies, 12 4/5. That's kind of, here, I'll write it right here. So we get 12.8 or 12 4/5. Yeah, that's better. So now our geometric, or our arithmetic mean or common difference is 12 4/5. So in this case, we're going to add. So we're going to add 17 plus 12 first, and then we get 29, and then we add 4/5. Now 4/5 plus 4/5 is 3/5. It was 1 3/5. So we're going to add 12 to 29, which is 41. But then 4/5 and 4/5 is 1 3/5. So we're going to get 42 3/5 because we have to add 1 extra. So 42 3/5, and then we add 12 and we get 45 1 2/5. I meant 55 2/5 because we add 12 4/5. And then I think you kind of get the pattern. So then we'll have here 78 1/5, and then we will have 91. Oops, 91. All right. Now let's get into some challenge problems. So we're going to start out with a geometric challenge problem. Okay. So we need 3 numbers between 7 and 112. So we're going to set it up the same way we did before. So we're going to take 7, r, which is our ratio, and we need 3, and remember we just add 1, so 7r to the 4th equals 112. Now we need to get r to the 4th alone, so we divide by 7, and we get r to the 4th equals 16. Now we see this r to the 4th and we want to get rid of that, so we take the 4th root of both sides. So we're left with r equals 2, because 2 times 2 times 2 times 2 equals 16. So now our geometric mean, or our common ratio, equals 2. So now we need to multiply each term by 2. But before you just go in and say, okay, this is 14, this is 28, and this is 56. You see how there's this 4 right here? Our exponent is 4. Now this 4 is both positive, so it's both positive, whoopsies, let's get that pen. So it's both positive and it's even. So like a little checklist right here. So this 4 is both positive and it's even, meaning that our answer can be both positive and negative. Because say you have 4 and you have positive 2. Positive 2 squared is 4, but negative 2 squared is also 4. So you can have a positive or negative answer. So this 14 can be positive or negative. But if you multiply a negative 14 by negative 2, you'll get positive 28. And if you multiply a positive 14 by positive 2, you'll also get a positive 28. So this one stays. But if you multiply a positive 28 by negative 2, you'll get negative 56. But if you multiply it by positive 2, you get positive 56. So this one's also plus or minus 56. So now here, so we have 7, positive or negative 14, because remember, this exponent for our ratio was both positive and even. So we have positive or negative 14, and then positive 28, because if you multiply by negative or positive, you get positive. Or if you square by negative or positive, well, yeah, you get positive. And then positive or negative 56. And then our last term of 112. Now our last problem for today, it is going to be an arithmetic sequence challenge problem. So we need to find two numbers between 67 and 90. So we take this 2 and we add 1, so we need 3. So we're going to write it 67. Remember, we're going to multiply 3 by our difference, and we're going to add that to 67. So times plus 3d equals our last term, 90. Now, first thing we need to do on our way to get d on its own is subtract 67 from both sides, and we'll get here 3d equals, what is it, 23. And now to get d alone, we divide by 3, and we will get d equals 7 2/3. So our common difference is 7 2/3. So we're going to take 67, we're going to add 7 2/3. So we get 74 2/3, and then we're going to take that and we're going to add 7 2/3. So 2/3 2/3, that would equal 1 1/3, and 74 7 is 81. So that would be 82 1/3. And just to check, 82 1/3 plus 7 2/3 does in fact get you 90. So that is correct. So thank you for watching. That was finding the missing numbers in arithmetic and geometric sequences. I hope you learned something, and I will see you next time. Bye.